Oh, that was funny. Oh my goodness, I bet everyone wishes they were here to have heard that. Oh, here we go. Here we go, right away, right away. A group of 18 people. You can wrap your head. I'm going to leave this on the board. I'm going to leave this on the board. Okay, I'm going to leave it on the board. A group of 18 people. 1 out of 20 people in the school volunteers every week for a charity. All right? The probability at least one of the group is a charity volunteer. Shake your head, you can get your mind around what the problem is. So you got a group of 18 people in the school, 1 out of 20. What is the probability at least one person in the group is a volunteer? Well, that would mean 1 or 2 or 3 or 4 or 5, which is a lot of work. So what we did yesterday, and this is yesterday's stuff, this is why I'm going quickly. I'm going to find the probability that nobody volunteers. I'm going to go with the probability that nobody volunteers for the charity. Make sense? And then the probability that at least one person volunteers would be 1 minus that. All right. Where is that? Doesn't matter. Doesn't matter. Doesn't matter. Okay. A person comes in that room. What is the probability that they are not a volunteer? 17 out of 18. Does that make sense? I'm sorry. I'm sorry. 19 out of 20. 1 out of 20 volunteers, so 19 out of 20 do not. Shake your head. So the probability the first person is not a volunteer is 19 out of 20. The probability the second person in the class does not volunteer is 19 out of 20. The third person, 19 out of 20. Make sense? Cool. And that all goes on for all 18 people. So it's the probability that you don't, and you don't, and you don't, and you don't. So that becomes 19 twentieths, and there are a total of 18 people. So here we go, 19 twentieths, the 18th power. Because here, okay, we have 1 out of 20 volunteers. So 1 out of 20 does volunteer. So that would mean 19 out of 20 does not volunteer. Cool? Good question, good question, good question. So now I'm doing 19 20s, parentheses, 19 divided by 20th, 19 20s to the up arrow of the 18 power because there's 18 people. And I get 0.397. Say, that's what I got. Cool. So the probability that nobody volunteers is about 39.7%. That is the probability that nobody volunteers. And the question was the probability at least one of the person volunteers. Would that be 100% minus the 39%? Say yep. Yeah. And so that would mean approximately 60.03 do volunteer. All right. And then let's run over here. Okay, if you don't want to be on YouTube, cover your face. All right. Here's the class. Okay. Oh, there. Oh, that was fun. Okay. Oh, okay. You see, this is why people have algebra parties. Okay. All right. There are 14 kinds of soda. Yum. Somebody randomly picks each week. Randomly picks one. All right. Pick one, pick one, pick one, pick one. The probability that at least one soda is picked multiple times in a week. All right. So we go about these by going with this. The probability that none are picked multiple times. The reason we do none is that's, yes?
Is it because we can't actually find out how, never mind.
Okay. It's because it could be 2 or 3 or 4 or 5 or 6 or 7, which would be more problems to do. All right. The first day of the week, you randomly pick a soda. What is the probability that you are picking one that's already been picked? It's not going to happen. I'm sorry. What is the the probability that it's not been picked before is 100%, right? Okay. Out of the 14 sodas, all 14 of them have not been picked before. Let me say that again because I think I said it well. The first day, out of all 14 sodas, none of them have been picked before. So there's they're not going to repeat. All right, the second day, you close your eyes and reach in, and it's all equal numbers of sodas. How many of those sodas could be picked that would not repeat? 13 of them. All right. And by the way, to be really specific, we keep refilling the refrigerator with equal numbers each day. Okay, here comes the third day. We're wondering if we pick one that's not been picked before. How many sodas, how many brands or kinds of soda have not been picked before on the third day? 12. The next day, 11. We're getting the idea. Yep. 10, 9, 1, 2, 3, 4, 5, 6, and 8. So on that last day, there are 8 sodas that could be picked that haven't been picked before. Some heads shaking that we're following. All right. So this turns out to be, and we showed you this yesterday, this 14, 13, 12, 11 becomes 14P7. 1, 2, 3, 4, 5, 6, 7. Out of the 14, you're picking 7. And the bottom is 14 times 14 times 14 times 14 times 14. That is 14 to the 7th power. And 14 math divided by 14. Is that about 16.4%?
Yep.
So the probability that every single day you pick a different kind of soda is 16.4%. If the question is what is the probability that you do pick something multiple times, that's 100% minus that, and that's 84.6%. All right. All right, all right, all right. Goodbye to the people at home.